I wish I knew these things when I was getting into knives. Welcome, guys. I'm doing like a 2 episode long sort of knife talk videos, which I'm trying to explain to you what, in my opinion, are the most important things to know about knives. Okay? Well, the reason I'm doing that, I had a couple of friends recently that showed more interest in knives and they're asking me questions. And like everybody that's new into knives, they're asking questions like, hey, what's the best steel and what's blah blah blah, this or that. And I'm trying to think about what the most important things are to tell them to understand knives better, quicker. And so I also thought I'm just gonna make a video or 2 videos actually about this topic. And in the first video, I want to talk about geometry, and in the second video, I want to talk about steel. Because usually new people in the knife community, and also some people that have been here in this whole knife thing for a longer period of time, usually ask questions like, what's the best steel? Which is a very weird question. It's hard to answer that, and it's also not well thought through in my opinion, because, well, that always depends on the situation, and you can't really say there is a best steel. So in my opinion, there is something even more important than steel, and that's geometry, which is why this first video is gonna be about geometry. And this took me a long time to actually realize that. And yeah, so I'm just gonna explain it to you really quickly so you don't have to watch like a really long video. And what geometry is in knives is basically that every knife has a blade stock thickness, right? And then a manufacturer grinds away material until they come to the edge or almost to the edge, and then they sharpen the edge. So you have the blade stock thickness and then the thickness behind the edge, and then you have your actual edge that cuts things, right? So I heard one knife maker say, actually he told this to me, he was like, it was like a really experienced bladesmith, and he told me one thing that I will never forget. I think it's really good and really important. He said, well, if you have a blade stock thickness of, it doesn't matter how thick or thin it is, usually the behind the edge thickness should be about 1/10 of what you have on the blade stock. And then you have usually a knife that performs really good for the purpose you have intended it to. For instance, if you have like a knife that has 3mm blade stock and you grind it down to 0.3mm behind the edge, then you get a really good slicer. But if you have like a fixed blade or some harder use folder that uses like 5mm blade stock, and then you grind it down to 0.5mm behind the edge, then you have yourself a really robust knife that can handle a lot of abuse, like chopping and doing a lot of stupid shit that you usually shouldn't do with your knife. So I think it was really good. 1/10 of the blade stock thickness is really good to have behind the edge. And then, but there's also more to that, because there's also a transition, right, on every knife. So you have your blade stock, and then you have the grind, which is the transition from blade stock to your actual edge. And most knives, or some knives, also do have a shoulder, unless you grind them to the spine completely, right? And so the transition is also really important. For instance, if you have a really thick knife on the spine, but you want to give it a lot of thinness behind the edge, you can, for instance, do a hollow grind. Because what hollow grinds do, I grabbed a little bit piece of paper to show you that a little bit better. So remove some of those knives right here. Let's say we have a thick blade stock, but we want a thin edge, so we have a hard use knife that can handle a lot of abuse, but still cuts really well. And we can do, for instance, a hollow grind to thin down that edge. Because if we would do the same, if we would have the same blade stock and do like a flat grind to meet that edge, we would maybe get a little bit of a wedge going on. maybe the Microtex Opium is a little bit of a good example for that. It's really thick on the spine, so you have a lot of strength up here for sure. And then they have a decently thin edge, but in order to grind down from a thick spine to a thin edge, they have to, and they did it with a hollow grind, they had, the result was that they were getting a little bit of a wedge. So you can see this if I show it to you like that in cross section. It's a little bit wedgy, the knife. And what that does is that this knife in certain scenarios tends to get stuck a little bit because it's so wedgy. And so you have to, I don't know, if you make a knife, you have to decide what kind of knife do you want it to be. Do you want it to be a thin knife with a thin edge that slices really well, or do you want to have like a thick knife with a thicker edge that's able to be abused a little bit better? So I think this is a really important thing to understand about knives, is that how thick is your knife up here, how thin is it down here, and how is the transition. I personally believe that a lot of knives would do better if they were thinner on the spine and also thinner behind the edge. Most manufacturers don't do that. They give you, for instance, the SOG Terminus right here. I'm not saying the SOG Terminus is a bad knife, but the SOG Terminus has a thin blade stock but a relatively thick behind the edge geometry, and it's also flat ground. So they didn't remove a lot of material because it just costs them less in production. And I do understand that. I still think this knife is great because the steel actually compensates for the lack of geometry here, which this is probably gonna be the topic for the next video, so stick around for that. Yeah, the geometry is not that good because it's thin up here but thick down here, which is not how it should be. It should be a little bit thinner behind the edge to actually cut better. And also, thinner geometry cuts longer. And that's also true for both the blades and the edges. I show you what I mean with thinner geometry cuts longer. Both of these knives right here have exactly the same steel, right? They are heat treated to exactly the same hardness, so in theory they should cut the same amount of time, so have the same edge retention. But this knife is really thick up here, and it's also a little bit thicker behind the edge, whereas this knife right here is thin on the spine and thin behind the edge, which means even though they use the same steel, this knife cuts longer and better. So it performs better as a cutting tool, but this knife is more hard use on the other hand. And it doesn't chip as easily if you do actually abuse it really hard. Whereas the thinner geometry can actually chip easier, in theory. Depends on the steel, the heat treatment, and how careful you are and how responsible you are with your knives, right? So yeah. Also, because we spoke about hollow grinds and flat grinds, for instance, what some makers do is they have a really thick blade, but they have a narrow blade, right? If you have a narrow blade, you have less time from the spine to the edge to thin out that edge. For instance, the Formax that I showed you before has a really wide blade, so the manufacturer had a lot of time to grind it out thinner and don't have a wedge situation going on. Whereas if you have a narrow blade with a thick spine and you want a thin edge, you get a wedge automatically because, you know, it looks like this. You have a thick spine and your edge is here and you get that wedgy situation going on. You can't, whereas if you have a wider blade, if you have a wider blade that uses the same thickness, but the edge is down here, you can grind it out a little bit thinner. So with a wider blade, you can get a thinner edge, even though you have a thick spine. And what, for example, Falkneven did here in this S1, they just did a convex grind, which is really smart because, like I said before, you can either do a hollow grind to thin out that edge, but then also you would get kind of a, if you would do that, you would get kind of a wedge with that short amount of blade. So what they did was they did a convex grind, which a convex looks thicker, but a convex has the tendency to not get stuck as easily as some of the flat grinds when you do actually cut wood. So I think convex grinds are really, really good for cutting wood. And that's why I like some of my Buck Rivers. And I also noticed that my camera is about to go out of battery, which is fine because I was done talking anyways. So yeah, I just wanted to say that geometry is more important than steel steel is also important. Uh, it's not nonsense to talk about steel, but the geometry is way more important in my opinion than anything else in a knife, and that's something that I wish I would have known before I was getting into knives. So yeah, that's it for this video. Next video, like I said, we talk a little bit about steels, and it's gonna be a little bit controversial, probably. I can't even speak anymore. Goodbye, people.